I'm here to talk about the potential cosmetic and social benefits of e-cigarettes and tobacco heating products. So I'm going to have a quick introduction about the products that we have available, some glow cosmetic and social benefits that we've already published, and the main talk of today is about the new staining methods that we've developed, and just give a quick summary at the end. So you've probably heard there's been other presentations from BAT where we've talked about our risk continuum. Our newer products are potentially reduced risk products that are actually available in 32 countries. And the two products I'm going to focus on today is our glow product, the tobacco heating product, and also one of our e-cigarettes as well. But I would encourage you, if you haven't actually had a chance to look at our products, do visit our stand, because we've got a number of these products available that you can actually find out a bit more information. We've also relaunched our website, which gives a lot more information on our products as well. So we have a 5-step potentially reduced risk product framework that we use. So first of all, we want to look at how our consumers actually use our products. So, these new products are quite different from cigarettes, so we want to understand how our consumers use them. Now, we have a poster outside if anyone would like to learn more about that. The next stage in this framework is actually look at the toxicants in the products and compare them to cigarettes. Next stage is we expose cells in the laboratory to human cells or 3D tissue and look at the responses. And we've published a number of publications showing differences in the responses in these cells. And again, we've got 2 posters outside. Chris spoke yesterday about some short-term and long-term clinical studies we do. And also, we look at post-market surveillance. And Jason gave a good presentation today on a post-market surveillance study we did. So the last stage of this framework is the population studies. So all this data together enables us to show that these products have potentially reduced risk. So recently we've become interested in what's, is there additional consumer benefits of these products, and that's what I'm here today to talk about. So we did actually publish some work last year where we looked at the indoor air quality and also odour of our glow product. So in this publication, we got consumers to use our tobacco heating product glow and also cigarettes, and actually in a confined space, we measured the particles in the room and also a number of toxicants. And we've shown in this publication that the toxicants are actually in the room are over 90% reduced, and the particles that are actually in the room are extremely low and lower than you see in an outdoor city, such as Southampton, where I live, and Warsaw here. So the publication also shows odour. So we got material and hair samples, and we exposed them to cigarette smoke and then also to the glow aerosol. And again, we saw significant reductions in the odour. And consumers' hands that used the products had, again, reductions in odour. So what we've been working on over the past year is actually looking at staining. It's known that cigarette smoke stained teeth, so it's one of the areas we actually wanted to look at. So we looked at methods that were available out there, and we used simple staining methods that the dental industry used to look at the effects of toothpaste or teeth whitening. So in these teeth staining studies, tobacco is used as a positive control. So we actually used methods out there and actually looked at stain build-up rather than stain removal. So then we wanted to see if we can actually use this method that we've developed for additional materials, such as wallpaper and material, and also skin samples. So very simple methods that we've developed, but you'll see from the results big differences between the products. So I'll first go through the in vitro staining assessment. So the test articles for these studies were a reference cigarette, 3R4F, our glow tobacco heating product, and also our iSwitch e-cigarette. So we either captured the particles produced by these products on Cambridge filter pads and extracted them in the solvent DMSO, or we exposed the samples to whole aerosol. So we used the cell exposure chamber that we've developed for cells, and we put our materials inside. And in this image, we've actually got some enamel samples within the chamber, and then we just put a number of puffs over the materials. So to measure the staining, again, we use a standard method that's used for dental staining, and we work with Intertech to develop this staining for our tobacco aerosols. And the staining's based on, there's a handheld spectrophotometer that can measure colour space at the light to dark, yellow to blue, or green or red. So you get the LAB values that can be then fed into equation, and you can look at the staining levels, the delta E, pre and post exposure. So the enamel work we did was at Intertech, and the skin staining work we did at IIVS. So in this slide, we can see the results of the porcine skin staining studies. And in these experiments, we used the captured particulate. So we captured the aerosols on Cambridge filter pads, and then we extracted them in DMSO, and then we incubated them with the skin samples up to 6 hours. So you can see in red the 3R4F. As you increase the exposure time, you increase the level of the delta E, the staining on the material. And on the image, you can see the samples at the start of the experiment and then at 6 hours. And you can see that 3R4F stains the tissue, whereas the values for Glow and iSwitch, our tobacco heating product, and the e-cigarette are very similar to the DMSO. And again, in the graph, you can see in the orange, green, and blue, the values are very comparable. So the next experiment is where we expose wallpaper and material samples. And again, we use the exposure chamber for our cells, and we put an adapter on the chamber to enable us to stick pieces of material and cloth inside the chamber. We then exposed the samples to 200 to 1,000 puffs, and again, we measured the level of staining, the delta E, which is on the graph, after each of the puff numbers. And you can see on the graph an increase in the staining, which then does plateau off after 600 puffs. But with our e-cigarette, iSwitch, and with Glow, the levels we see are minimal. Now moving on to the enamel staining, we use bovine enamel. This is standard in toothpaste and dental studies, as I said before. And you can see on the graph the level of staining with the increase in the puff number of 3R4S. Again, you see increased staining, but with iSwitch and with Glow, the levels are minimal. And in the image, you can see after 1,000 puffs, the level of staining with the 3R4F reference cigarette, Glow, and iSwitch, and there's big differences between them. So more recently, when we're actually doing these experiments for our potential reduced risk products, we've actually used air experiments as well. So just put air over the teeth and actually see what the staining levels are up to 1,000 puffs. So what we found that with our products, the values are comparable to air. So we've also done a pilot clinical study, and this work was done with Alba Sciences in Edinburgh. Very small study. We had 32 smokers, 27 e-cigarette consumers, and 35 non-smokers. And qualified dentists assessed these subjects. He looked at the staining in the subject's teeth by the modified Lubin tooth staining index. So he assessed the level of staining on the front 12 teeth of each of these subjects. And he measured 4 areas. So he measured the side of both of the teeth, next to the gum, and actually the body of the tooth as well. And in each of these areas, he actually looked at the intensity of stain and also how much of that area is actually stained. So this graph gives you the data we saw from this pilot clinical work. We did see some differences between the smokers, the e-cigarette users, and the non-smokers, which was very encouraging. The data was variable, but one thing I want to point out, this was actually a single analysis on these subjects. We also didn't control for lifestyle factors, coffee, red wine, how often they brushed their teeth. So it was a single point analysis, but very encouraging because it was comparable to what we'd seen in the lab. We saw differences between exposure to cigarette smoke and the e-cigarette aerosol. E-cigarette users were higher than non-smokers, but all these consumers were formal smokers, and we don't have the data to know when they actually had last time had their teeth cleaned. So pilot work, but very interesting. So just to summarise, I hope you can see from what I've presented today, our potentially reduced risk products. We saw minimal staining of enamel, skin and wallpaper when we actually exposed these. There was big difference between the reference cigarettes. A lot of the studies we're seeing is over 90% reduction in staining. The skin studies we did use the particulate matter, the particulate phase of the test article. We are looking to do aerosol studies because this is more comparable to how consumers use our products. In the pilot clinical study, the e-cigarette consumers did have reduced teeth staining, but further studies are actually needed to understand the changes in consumers' oral cavity when they actually switch to these products. And the next presentation, I hope we'll find more information about that. But I hope you can see from the data that I presented today, our products have potential cosmetic and cosmetic and social benefits for the consumers that switch to the products. So I'd just like to thank the companies that worked with us on these studies and also the people at R&D that supported the experiments. Thank you.